All right, this is lesson 98 on scale and scale model. You've probably heard the term scale model before, so think about a scale of something. So, for example, maybe there is a large battleship out there and someone's made a scale model of it. That means that they have made something a lot smaller that is still proportional to that original large battleship. So it's kind of like the similar triangles thing where you have a similar, smaller object that matches a much larger object. Those objects are still proportional to one another. So scale models are reduced or enlarged copies of the actual thing. They are similar, which guess what? Since they're similar, we are going to use proportions again. In number 1, we have a model airplane that has a scale of 1 to 24. That means for every inch on that model, you have 24 inches on the real thing, or for every foot on that model, you have 24 feet on the real thing. So that model is 1/24th the size of your original airplane. So I'm going to use that in my proportion. So I have 1/24, the top being the model and the bottom being the real one. And so I want to know, so the wingspan of the model is 18 inches. I want to know what the wingspan on the actual plane is. Well, so 18 is the wingspan of the model. So model is in the numerator. I need my 18 in the numerator. And I'm trying to figure out the wingspan of the actual plane. So I'm going to say W for wingspan. So guess what? Proportions, cross multiply. So I get that 1W is equal to 18 times 24. I'm going to save you a little bit of work here, guys. Don't tell anybody. 432. And this is going to be in inches. So the wingspan is 432 inches on the actual plane. That's not very practical. It asks for how many feet. So in order to figure out the number of feet, I got to divide by 12. And my wingspan is going to be 36 feet on the actual plane. This one, Jalen has a model car. So my scale is 1 to 36, so that's the proportion that I'm going to start out with. The car's height is 4 feet 6 inches. Well, I've got some mixed measures here, 4 feet 6 inches. Let's convert that just straight to inches so that we're going to have a little bit of an easier time multiplying it. So 4 feet, 4 times 12 is 48. So I get 48 plus that extra 6 is going to give me 54 inches. So the 54 is what I'm going to use in the problem. So this is the actual car's height. That's 54. So my actual car's height, this was the model. This is the actual car. So my 54 this time is going to go in the denominator. So that is something you have to pay attention to, where the number goes, numerator versus denominator. And so I'm looking for the model's height in inches. Cross multiply. We get 36 is equal to 36m. Don't forget your variable. Divide by 36. And 36 goes into 54. You do long division on that. Again, I'm going to save you. Here we go, 1.5. And then my units on that one are going to be inches because I converted this guy to inches. So, and that makes sense that I want 1.5 inches for the smaller model car. So 1.5 inches on that. All right. Scale factor. Similar to the idea of just a scale of something, which was something that's proportional. Scale factor, what we're going to do is we're going to take the size of a figure, multiply it by the scale factor, which is a number, and we're going to get the size of your second figure. So here's how we figure that out. So I have two triangles that are similar, triangle A and triangle B. We're going to pick a set of corresponding sides. It really does not matter which set of sides you pick. I don't know, I'll do 16 and 20. So I'm going to take the smaller side. If I'm trying to figure out from A to B, I'm going to take the smaller side of A. I'm going to multiply it by my scale factor, and I'm going to get the length of triangle B. So let's actually figure out the scale factor. Divide by 16, and then your scale factor here, well, I'm going to reduce that fraction, and I get 5 out of 4. So my scale factor is 5/4. Well, guess what? If I do 20 times 5/4, I'm going to get 25. If I do 12 times 5/4, I'm going to get 15. So it doesn't matter which set of sides you choose. So it tells you that triangle B is 5/4 the size of triangle A. We usually will keep scale factor as an improper fraction rather than changing that to a mixed number. You just don't usually see scale factors as mixed numbers. All right, fourth one. We've got these two rectangular prisms. We're going to change dimensions here. So I'm going to get the scale factor for just the side, then I'm going to start with area, then I'm going to do volume. So let's start with letter A. It just wants the scale factor from the smaller to the larger. So that means a set of sides. So let's match up. It doesn't really matter which set of sides. Let's 2 and 6. I know it's kind of smushed. It's a 6. So to get from 2 to 6, well, I times by 3. So my scale factor is going to be 3. And I can verify that 3 times the scale factor of 3, yes, gets me 9. 4 times the scale factor of 3, yes, gets me 12. So my scale factor is 3. Let's look at area, though. So the area of any face is how many times the area of the corresponding face. So let's figure out the area of one of the faces. I'm going to use this darker shaded face in the front. So my area for the first one is 6. My area for the second one is 6 times 9 is 54. So that means that the area of the larger one is 9 times the area of the smaller one. So I have a ratio really of 1 to 9 with my area of my smaller area of the larger face. Let's look at volume. If I'm trying to find the volume of each one, I want 2 times 3 times 4, which is 24 for the volume of the first one. This one I want 6 times 9 times 12, which of course you know that off the top of your heads is going to be a volume of 648. And then, well, let's figure out 648 divided by 24 gets me what? So, or backwards, 24 times what number? It gets me 648. If you do some fun long division there, you're going to find out that it's 27. So if I multiply by 27, I get that. So really, in my volumes, I have a ratio of 1 to 27. Those numbers should be interesting considering your scale factor of 3, right? So I had area, which is in 2 dimensions. That's 3 times 3. So really, this is a ratio of 1 to 3 squared. Well, and volume is 3 different dimensions. So I have a volume of 1 to 3 to the, not the second power, wrong, the third power, because 27 is 3 to the third. Go ahead and pause the video, and then you're going to do 4 and 5 on your own. Check your work, and then if you missed some of them, you can watch the explanation for it. Here are the answers to, not 4 and 5, like I said a second ago, 5 and 6, sorry. So you get 18 inches, and then you get that x is 2.5. If you missed either of those, I'm going to do those in a second. All right, so we have a model ship. Scale is 1 to 36. If the ship is 54 feet long, well, 54 is the actual ship, so 54 goes in my denominator, and I want to know the length of the model. So I get cross multiply, and I get 36m is equal to 54. That's actually the exact same division problem we did up top, and you get that the model ship is 1.5, and my unit is going to be in inches. Oh, I'm sorry, not in inches. 54 was in feet, so that means I have 1.5 feet, but I want my answer to be in inches, so in order to convert it, I'm going to multiply by 12, and then so I get 18 for my inches. This one you're finding scale factor from the smaller to the larger. So if I'm starting with the smaller, I got to go over here to start. So you pick a set of corresponding sides. So I'm going to pick these. So I want 10 times my scale factor to give me the larger one. Divide by 10, and your scale factor is going to be 2.5. There you go.